Alright, hello everyone. Today we're going to be talking about dynamic equilibrium a little bit more. So in the previous video we had a look at those graphs and what equilibrium actually means. But we're going to talk a little bit more about activation energies for forward and reverse reactions for dynamic equilibriums. So if we look at this top equation here, we have the general formula for a reversible reaction. So we can have the forward reaction and we can have the reverse reaction this way. Now, both of these directions, forward and reverse, they both require energy to occur. So A and B will require some amount of energy. I'm just going to put E here. It's going to require energy to form C and D. So A and B will need energy to create C and D. Okay, and the same is also true for the reverse reaction. So C and D will need energy to become A and B. And those activation energies are usually different. So if we look at the bottom one now, we're actually showing the self-ionization of water. So water has this property where it can ionize into hydrogen and hydroxy ions. So that's a characteristic of water, is its tendency to self-ionize. Alright, so it's a reversible reaction. So we can have the forward reaction and the reverse reaction occurring. But the important thing about this one is the activation energy for water to become ions is quite high. So the activation energy, now this is sometimes called, that can mean activation energy. This is very high, okay? It's a high activation energy. But the reverse reaction is very low. So what does this tell us? Well, it means that more energy is required for water to break down into hydrogen and hydroxy ions, which means that it's not going to happen as frequently as the reverse reaction, because it's easier for the reverse reaction to occur, which means that in equilibrium there will be a higher concentration of water than hydroxy and hydrogen ions. So that means that the equilibrium, or the reaction, sits more to the reactant side. So the reverse reaction is favoured because of the lower activation energy. It's easier for the reverse reaction to occur than the forward reaction. Right, that's just another thing to note with dynamic equilibrium. The concentration for this one, concentration of reactants will be higher than the concentration of products because of the activation energy. So just one small correction with this one is delta H isn't activation energy. That's actually enthalpy change, and that's something different. So instead of delta H, it is just usually EA for activation energy. Okay.